Hi everyone, welcome to September's edition of AI Talks, sponsored by Berrijam and Canberra Innovation Network. This is a second recording, as unfortunately yesterday's session we had some technical difficulties and we couldn't record the talk itself. And so for those of you who were not able to attend in person or remotely, um, we wanted to make sure that you have access to what was shared and so that you can keep up to date, but also participate in discussions around this. So we're going to do another recording, and this time it's without the audience and all the chuckles and laughs. But let's get straight into it. Before we begin, though, I do want to acknowledge the Ngunnawal people as the traditional custodians of ACT and the surrounding regions in which we meet today and we met yesterday. We would also like to pay our respects to the elders past, present, and emerging. With that, today I'm going to talk a bit about generative AI. Now, everyone's very excited about generative AI. Everyone's heard about ChatGPT and the potential it happens, but also hysteria, excitement, hype, but there's also a lot of pragmatism and practical uses for this. So there's a great opportunity to harness the power of generative AI if we use it effectively. So today I'm going to give you an introduction into the context surrounding generative AI capabilities. And along the way, I'm going to be using analogies and frameworks that I use to make myself more comfortable understanding the implications of different pieces of news that comes along the way. So if you have any questions, feel free to email me or post on the video itself. My email is avishkar@berrijam.com. So where does AI fit in and what type of AI? So I like to see AI not just across the multiple techniques that are available, but in context of how we capitalize and use different capabilities of AI. And in my frame of reference, when you look at it from that perspective, there are really four types of capabilities of AI that are typically very, very beneficial to harness for people. The first is to find connections. AI is really good at mining through different dimensions of data, especially high dimensions of data, looking for patterns and correlations and relationships that help us find factors that are related, that are important. And this is something that machine learning and AI algorithms can do really well, right? And once you can understand those patterns to understand what is related, then you can also make predictions. So for example, if you understand that certain blood chemistry levels are indicative of a patient having a certain medical condition or even being readmitted, then it opens us the possibility to make predictions about unseen cases, right? And in that way, that unlocks the second capability of AI, making predictions. And the predictions could be from everything from yes or no decision making outcomes, like is this patient going to get readmitted? Yes or no. Is this machine going to break down? Yes or no. To next best action or offer. You'd think about product recommendations when you look at Netflix or Amazon, when you're watching videos or looking at products, what product is being recommended to you is an AI driven capability. The other thing that we often want to make a prediction about is predicting price or a quantity. How much should I sell this house for? What should be the number of units of this product that I should produce? Things like demand forecasting and so forth. They're all making forward looking projections and predictions that are used by individuals, organizations day to day. The third capability we're all very familiar with, I'm sure, is finding things. So when you've used Google or Bing to search, you are basically harnessing the find things capabilities of AI. If you're not familiar with Amazon Lens or Google Lens, it's where you take a photo and you use that photo to search other images or products in the catalog that could be of use that or interest for people to buy. So that's finding things, not just text, but images. Similarly, with medical domains, is often looking at, given this particular patient study, can you find other examples of other patients and the treatments that fit into the space? There's lots of interesting use case of it. The fourth area of capabilities that AI is often used for is making things. This is the category in which generative AI sort of fits in, whether it's Mid-Journey, which incidentally was used to make all of these four images using simple prompts, or generating deep fakes, where you can pretend or generate synthesized audio and video for people, as well as Chat or GPT or Bard, or Meta's Llama models, which are interactive chat-like conversations, right? So those are the sort of the four broad capabilities of AI that we often like to look at things in lens with, right? So if you think about generative AI, fits in the make things category, right? Um, so what does it really mean? Let's take an example. Some of you might be familiar with this seminal work by this amazing Japanese artist Hokusai in 1831. It was a print of the Great Wave off the coast of Kanagawa. Now, naturally, that artist is no longer around. I love this artwork. It's got a sort of feel for it. Um, but now, if we could use, and we did use generative AI, we could give it a prompt and it would generate a 3D version of the artwork in that style, right? And here the artist is Midjourney, not the person providing the prompt, or is it? Right? And so this is an example where generative AI techniques can be used to harness or create or imagine things with the lens of different artists, different styles, different contexts, and it's able to generate artworks that fit that sort of description or context, right? Um, so in short, generative AI is the type of AI to create new content. Whether it's text, whether it's images, like we just saw. You can even generate music and synthesize your own style of music, given the feel and emotion that you want. You can synthesize audio. You can have people generate and synthesize their own voices that could be used to speak and say a text. There's also synthesizing videos. Bottom line is you can synthesize data, right? And synthetic data unlocks all sorts of capabilities. Imagine 3D models for games. Imagine synthesizing proteins for drug research. Imagine synthesizing different types of data sets that help you preserve the privacy of the original data set and yet allow statistical models to be used in finding patterns and relationships across large volumes of data, right? And so there's lots of interesting use cases around how we could use generative AI, um, but and including chatbots, right? So chatbot, everyone's heard of ChatGPT, played around with it. The original OG chatbot is actually Eliza, created in 1966 by Joseph Weizenbaum. And here we had a chat-like interface where the user can type in a statement, and the bot would Eliza would respond and prompt for questions in a sort of a therapist, sort of a counseling way. Now, naturally, Eliza wasn't very intelligent, capable, and was really, mostly responding to certain keywords that were important, right? So Eliza would notice those keywords in the statement and then respond to it as the user would type it in, and embark on a sort of a Q&A sort of a style sort of discovery, right? Now, why were we inventing or trying to invent chatbots back in 1966? Right? What's the point? Because, like, I'm sure we didn't really have chatbot for customer support. The real reason behind chatbots really came about because of this guy called Alan Turing. Alan Turing, who is recognized as one of the leaders in computer science, and the Nobel Prize equivalent in computer science is the Turing Award. Um, he in 1950 wrote a paper introducing the Turing test, and the idea behind Turing test was to look at, well, how would you recognize intelligence or artificial intelligence when it's there, right? How do we know? And the idea was very simple. The idea was to say, look, if I was sitting in a room and I had in another room a computer and a different room a person, and I don't know which is which, and I can communicate with either the computer or the person using written text or printout of text, and have a conversation with both of them. And if at the end of it I cannot tell which is human, which is machine, then we've basically created intelligence that matches or mirrors human intelligence. And that was a sort of like the Turing test, which was sort of like a simple way to benchmark intelligence that people were trying to invent and create. And so that is why Eliza in 1966 was one of the ones that people were looking to sort of mirror and win, succeed at the Turing test. Now, Turing test has some limitations, but it was a pretty good sort of approximation to try and start a conversation around what is intelligence. Now, that was 1950. Turing test was introduced. 1966 was ELIZA, somewhat limited. Fast forward to 2022. June 11, Washington Post talked about how a Google engineer um, really thought the company's AI had basically become sentient, had come to life, right? And so here's an example where a Google engineer was fooled by the metrics of essentially Turing tests to believe that the Google's model or AI, generative AI model, was sentient or self-aware. Now, full disclosure, Google did go and investigate these claims and repeatedly asserted that all their investigations found that there was no such sentient existence. There was purely a generative model that is very good at mimicking human conversations and drawing upon knowledge and emotions and so forth. So it was a very, very interesting and telling time that from 1966 to now we have made tremendous progress in building chatbot or through generative AI techniques that have been very successful. That was June. By November 2022, ChatGPT 3.5 was launched by OpenAI. Now, arguably, this has been a long journey and there's been a lot of versions, but this was something that took the interest and imagination of the world by storm, right? 1 million users in 7 days, 100 million users by February 23. That's one of the fastest uptake of a product out there in history that we know of, right? So it's been phenomenal sort of success, and it's also come with a lot of interest, but a lot of anxiety, a lot of fear, a lot of apprehension, but a lot of opportunity as well. And this is where we right now are with the whole excitement around generative AI and chat GPT likes technologies, right? But how does it work? Right. So for those of you who are really into getting into the depths of it and learning the details, this is take home exercise. Just go to ChatGPT or Bard and type in a prompt. Explain to me like I'm a 10-year-old, 15-year-old, 5-year-old in some cases, how different techniques or tools actually work. These are some of the key pivotal innovations: diffusion models, variational autoencoders, generative adversarial networks, and transformers that really have been pivotal in making this technology a reality. But for the rest of us, I'm going to give a very, very quick sort of fundamental overview. Generative AI really is based on much, much more advanced version of essentially a fundamental idea called neural networks. Neural networks were first proposed in the 1950s by Marvin Minsky. And then, of course, there's a lot of research in the 60s, 70s, before the winter, the AI winter, where people sort of started to feel disillusioned by neural networks. So in the 90s and 2000s, when they had advent of a lot of data and a lot of strong computational powers through GPUs, suddenly their real potential really unleashed. But fundamentally, neural networks were inspired by neurons and the connections between neurons in the brain. And the idea is that each of these circles, dot, represents a neuron, and that's connected to another neuron or node. And that connection either bumps up an incoming signal or dampens it, right? So if it agrees with the what that neuron is trying to do is to either bump up a signal or dampen it, and you have connections from one layer to the next layer to the next layer. So imagine a signal propagating through the network from input from one end and all the way through the other side as output. In this particular toy example, we have 4 input nodes, and they're connected to the next first layer of hidden layer, and which is connected to a second hidden layer. These are hidden in the sense we don't observe them except through the other nodes. And then you have 4 output nodes where the signal ends up. So the connections between this is a fully connected network, so every node connects to the next one in the next layer. You're looking at around at least 33 parameters, if not more, which defines the number of nodes or number of layers and so forth. And that practically represents the fundamentals of neural network, right? You've got information coming in that is being bumped up or combined with other information coming from other places and then propagated. And when you go through that network, you can then approximate and make decisions around very, very complex things. And there are different ways and forms to train the weights and figure out whether the weight should be bumping the signal up or dampening it. That's done automatically through a training process where it's called back. One of the simple one is the back propagation algorithm that does this. But that's for you, for everyone who's interested to dive deeper. But now that we've got these neural networks, what does it mean for the big neural networks that we're talking about, like ChatGPT, for example? So here we have data. When you combine lots of data with lots of compute and given time, you end up with a trained neural network, which is relatively big. And we're talking about time in terms of weeks and months, not minutes or hours, right? It takes a lot of time to build and train these large models. Well, how large are these models, right? So here are some examples, like Stable Diffusion. You're looking at about 890 million parameters. ImageGen with 4.6 billion, GPT-3 and Claude, they're looking at about 175 billion. Llama 2 from Meta has anywhere from 7, 13, or 70 billion parameters, depending on the version that we're looking at. And just for reference, I know it does not translate directly, it's not a like to like comparison. The human brain has 86 billion neurons, but 100 trillion connections. So if you think about 100 trillion connections, each being a weight that needs, which represents a variable, you're looking at 100 trillion in a human brain versus the largest models here, we're looking at 4.6 billion or, sorry, 70 billion, 175 billion sort of parameters. Now, let's look at each of these components that go into the recipe of training a large neural network. The first is data. So, where do we get the data? A lot of the organizations that have been training this have been using data from the internet, or which is either scraped from different sources or curated and labeled or tested and verified, but also large variety of it is completely just taken from books, from images, from artworks, and so forth. The compute time is, we use a lot of not just one CPU or one machine. These large models can't be trained on a single box. They really need a number of machines, and in fact, they need specifically a GPU. A GPU is a graphic processing unit. One of the key benefits of using a GPU is that it can do a lot of computations which are required for training neural networks in parallel, whereas a CPU, a central processing unit, which is what you're really typically used to in your computer, can only do a few of those operations sequentially, largely sequentially, and few in parallel. Why is that important? Well, it's important because one of the biggest providers of GPUs is actually a company called NVIDIA. So if anyone's interested in the impact around generative AI and the excitement around it, all you need to do is look at the stock price of NVIDIA from October 2022 versus today. I think it's a 3 to 4x change. NVIDIA is one of the leaders in this space, but others are coming along for the ride. Now, when you're running a lot of compute through the GPUs, you need a lot of electricity, and there's also implications of water because water is used to cool some of these data centers because it generates a lot of heat. Just for, some people have estimated different amounts of water and electricity that's used. One approximation was that when you have a 20 question back and forth interaction with ChatGPT, you're basically using half a liter of water, fresh water, to cool these systems, right? Now, that doesn't sound much, but when you combine it with 100 million users all doing one sessions per day, that adds up very, very quickly. Similarly, electricity. Now, of course, they could be coming from renewable sources, but there is an impact of this as well. So some people have estimated that it takes about the same energy as what 2 humans would take in an entire year to train a ChatGPT model. Right Now, the reason I'm laying these pieces out this way is for everybody to start appreciating the nuances of different elements that at play that go into building a large generative model or neural network. And those, when you hear about the implications of these, look at it with the lens of where these pieces fit in, right? Now, neural networks are great. ChatGPT is great, but there are some issues, right? So one of the first things you can already think about, it takes months to train. So the data that comes from the internet may be outdated. So sometimes the recommendations or the generated content is really outdated. The second thing is sometimes it's inconsistent, right? You ask the same question multiple times, you get different versions of answers. The really scary one is when the when the bot or the generative AI model doesn't really understand the context or doesn't have an answer, starts to hallucinate. There's a famous example of a lawyer in US who cited 6 fake cases made up by ChatGPT and got in a lot of trouble with the judge. Right? Basically, the lawyer did not verify and check the output produced by ChatGPT and made a submission, and turned out it was all made up. Right? Big issue. So you've got to take the output that ChatGPT or generative AI like solutions produce with a grain of salt. You have to verify its consistency. The other big issue around generative AI that will get a lot of attention and continues to is around copyright. A lot of artists, comedians, performers draw, who are basically suing companies like OpenAI, Microsoft, Meta, Google for using content that they have produced outside what is constitutes fair use, right? And so under fair use, you're allowed to reference and use something that someone's produced when you're providing a critique on it, or you're providing it for parody, or when you're building something. But now what you have with ChatGPT, Midjourney, generative AI capabilities is you've just empowered everyone to duplicate an artist's work with a few words, like I did earlier, right? So we can very easily see how these solutions are not something artists are welcoming, and they're really concerned about it because now everyone can steal their particular style and create art or solutions that they would have been compensated for normally for creating it, but without any compensation, any reward. And there's a lot of legal cases that are around what's the fair compensation around this, and so that's going to come in some cases. The other big issue is deepfake, right? The chat GPT can be used to basically um, get any politician to say anything, get any, which mind you, they might already say it, but the point is this can be really harnessed for spreading misinformation. And it's a real big risk amongst older generation who's not really actively using generative AI, so is not familiar with the risks involved with it. So they're more likely to fall victims of scams that defraud them or steal their money or steal their information. We've seen lots of these cases come up already where you had really dodgy people tricking people with celebrities endorsements that the celebrities hadn't actually made, right? So there's a lot of concerns and risks around this. The volume of data and where the data comes from, how it's harnessed and used is has potential for abuse and misuse. So we've got to be very careful how we harness generative AI and put in the right guardrails in its use. So what are its applications? Right, and so the go-to answer for most people tends to be, oh, generative AI will replace humans. But in reality, that is not really going to the place. What's going to happen is generative AI, when combined with a human, is going to lead to better productivity, better bigger outputs, and more faster results or deliverables than would be possible with human alone. And by having the human really as the pilot guiding the generative AI, you're really unlocking both the creative abilities and contextual abilities of a human, the judgment of a human, as well with fantastic generative capabilities that generative AI has. And there are hundreds of possible use cases, applications that are, people are just still exploring, inventing. Anywhere from a smarter version of Alexa or Siri to assists for programmers or artists, productivity tools. Think about customer support, where instead of walking through the phone banking system where you got to select option one, option two, listen to all these options, then make the next selection, you can simply have a much more natural user interface. You speak it, the system understands it and guides you to the area which is most likely what the information you're looking for. And you give back people not just more a sense of better control and experience and what they're doing, but also give back time, right? You've just saved them minutes or hours in some cases, considering how long call center waits can be sometimes, down to a few seconds or minutes to achieve what they want to do. Personally, I'm a big fan of the potential for generative AI to serve as a personal tutor. Right now, imagine there is a shortage of teachers, educators, talented around the world, and there are. If you're lucky, your students to teacher class ratios are, for every one teacher, you've got 30 students or 20 students. Now imagine if that ratio was 1 to 1. Imagine if it was especially the case in developing nations where each student is paired with a personalized tutor who is able to help and articulate and present the information multiple ways, and over time learn the specific needs of that student. You are now really harnessing generative AI in a very, very productive, beneficial way to empower, educate, and bring up the next generation of leaders that's going to lead the world, right? And so there's a huge potential to equalize and democratize AI, but by also democratize knowledge and access to education through it. Now, this is all great. This is fantastic. There's a lot of potential that we're talking about here. What about why does it matter? Well, it's the economic impact of this is massive, right? We're Everyone's interested in what is the potential impact of generative AI. McKinsey did this analysis, which was really interesting, worth checking out. They looked at generative AI as impact across different industries, right? And they've sort of estimated that the incremental benefit from generative AI is somewhere between 2.6 trillion to 4.4 trillion globally, to the entire global economy. And for reference, UK's 2021 GDP was 3.1 trillion. So imagine entire countries, one of the top 10 sort of GDP nations being added thanks to this particular technology if its potential is fully realized. And if you notice the chart, you've got sales, marketing, software engineering for corporate IT, but also software engineering for product development, customer operations and support, but also product R&D. These are very, very lucrative places for generative AI to have an impact. In fact, they represent 75% of the value that people think we're going to gain out of it, right? So those are the areas where applying generative AI is likely to be much, much more impactful and beneficial. In other places, if you look at supply chain, manufacturing, finance, risk and compliance, pricing, procurement, there are some benefits, but not nearly as much. And the reason for that, I believe, is because the benefits will come in terms of a natural interface and streamlining the interface, but the solutions and decisions and the analysis that's necessary is very didactic. It's very, very precise. It needs to be structured. It cannot tolerate the hallucinations or errors that can sometimes creep in. Whereas in the other domains, you, with the human in the co-pilot seat, you can actually sort of deal with those hallucinations and be corrected by a human. In these domains, in finance, you don't want to hallucinate a company's financial numbers. You don't want to hallucinate how many numbers or units or product I should be ordering, or hallucinate if a machine is going to break down. Those things need to be much, much more certain, precise, and grounded in statistical modeling, right? Oh, by the way, That potential that we talked about for generative AI of 2.6 to 4.4 merely represents 15 to 40% incremental benefit. There is 11 to 17.7 trillion dollars worth of benefits using traditional machine learning and deep learning models for advanced analytics, right? So while there's a lot of excitement with generative AI, we see it, there's also a huge amount of opportunity using some of the techniques and strategies that are better understood and better applied, or could be better applied to all sorts of domains. And part of the reason is that AI is just so new, and the technology and capabilities um, are not used by most organizations. Most organizations do not have the talent, the skill set, the ability to harness the technology of AI to make smarter and better decisions. And that's part of the reasons why we've been working at Berrijam, is to democratize and make AI accessible and simple for people to use. So there's a lot of potential here where you can use AI, and those are the techniques, not just the generative AI. When you look at finding connections or making predictions and finding things, there also represents a large chunk of applications that we really shouldn't ignore. So finding things, making predictions, finding connections, they're all relevant, important applications of capabilities from AI. And in terms of making things in generative AI, is phenomenal potential there. Now, that was the session today. We apologize. We had some issues recording it yesterday. Hopefully, this is useful for people who couldn't attend or wanted to review the content that was presented. If you are interested in joining us for the next talk scheduled for the 12th of October, um, Hamid Abu Abu um, Mr. Hamid Abu Tarab. I'm sorry I got messed up, mangled your name, is going to be presenting how AI is used to identify risk in supply chain. Supply chain has a huge impact, and if we can get ahead of using AI techniques to identify the risk early enough, and then we can reduce the impact of it. So if you're interested in joining us and learning more about it, or even joining the community around AI talks, just send an email to that's JAG at berryjam.com, or sign up at AI Talks on our Berryjam's website, and we would love to have you there.